Okay.
So before we continue, I have a question, sir.
Please, I've started recording after the class, okay? So greetings to everyone. So you are welcome to this class where we are going to consider the problem we've started. We are learning how to solve differential equations. So permit me to share my screen with you. Okay. Okay. Okay, I believe you can all see my screen now.
Yes, sir.
Okay. So,
Yes, sir.
Like I've said earlier, I said there are two cases. Let's start with the case of homogeneous, like you can see on the screen now. In this case, we can see now that the f of x is what is 0. That is in equation 1. And how do we go about it? You assume a solution exponential mx. You will notice that in the first case, we normally assume solution y equals to a exponential mx, if you remember. And I said, even if you assume a exponential mx and you assume exponential mx, they're all the same. Okay, now if you assume exponential mx, then you differentiate twice because you are solving second order ordinary differential equation. You need to differentiate twice. Then you substitute to the problem, then you factorize. And when you factorize, you notice that exponential mx is indeed the solution we assumed. So the solution we assume can never be 0. So definitely it is the multiplier that is 0. So we now say exponential mx is not 0, but the coefficient, which is am squared plus bm plus c is equals to 0. And then if you solve this case now, there are three cases involved. Now let's talk about the three cases now. The first case is if you have the same roots, then this would be the solution. If they have equal roots, in this case, we have m1 to be alpha, we have our m2 to be alpha. This is what we are going to obtain. And I said in this case that for us to obtain a non-trivial solution, we need to multiply one of the components of the solution by x. That is why here we have as exponential alpha x plus b exponential alpha x. Please don't forget that this issue of adding x. Now, the third case is the case of complex, which I've explained to you before. So we are going to proceed now to today's class now. In today's class, we've started, we are going to continue with how to solve non-homogeneous. And the method we are using is called the method of undetermined coefficients. So how do we go about it? The first thing is this: the final solution, which is y, it must be the addition of complementary solution and particular solution. What do I mean by the complementary solution? It means that the solution of the problem when f of x is 0. Now, how do we get the particular solution? Before we obtain the particular solution, we need to also assume a solution. We need to assume a particular function. And what we are going to assume will be dependent on the nature of our f of x. That is why I put that it depends on the nature of f of x. Now let's consider case number 1. This case number 1, you see it in page 482 of the textbook I shared with you. And I said in this case, if our f of x is constant, example is here. You can see now that here our f of x is what? Is 4. So how do we get the complementary solution? We follow the procedure that I've explained to you earlier. And by the time you follow the procedure, you will see clearly that your complementary solution is a exponential x plus b exponential minus 2x. And by the time you obtain the particular solution, you will see that in this case, a particular solution will be k, because f of x is just a constant. Before we proceed, is there any question on this?
No, sir.
Any question on this before we proceed?
No, sir.
Okay, now thank you very much. Let's go to the second case now. This is case 1. But in this case 1, f of x is a constant. But one of the components of the complementary solution is a constant. What do I mean by that? By the time you solve, you obtain the solution of the complementary parts, you will get a complementary solution. And when you obtain the complementary solution here, you will see that your solution will be a plus b exponential 3x. When we are through with this lecture, you can go and take a look at page 483 of the textbook I've shared with you. So in this case now, we have constant, but one of the components of the complementary solution is a constant. So we cannot assume the particular solution to be constant again, but it's going to be constant multiplying by x. So is there any question on this?
No, sir.
Everybody, can you obtain complementary solution by yourself? Everyone in the room, can you obtain the complementary solution by yourself? Hello, class. Hello, everyone. Hello. Are you with me? Real one, I can hear you clearly. Real one, I can hear you clearly. Aha. Okay. Hello, guys. Okay, can you hear me clearly now?
Yes, sir. We can hear you. Yes, sir.
Thank you very much. It's raining here in. Somehow the weather is somehow. So let's proceed now. So I need to share my screen again. Okay. Sorry for the interruption. Okay, can you see my screen now clearly?
Yes, sir.
Okay.
Yes, sir.
So let's proceed. Now, look at this case now. I said, can you all obtain the complementary solution in this case?
Yes, sir.
Okay. Now, look at the particular solution that I assume. I assume y of p equals to k multiplied by x. Why do I need to add x? Because there is a constant already in the complementary solution. If you look at the complementary solution, you see that it's a combination of a and b exponential 3x. Do you notice that? So because there is a constant in the complementary solution, I cannot assume my particular solution to be ordinary k. It must be k multiplied by x. Okay, now let's proceed now. Now, case 2 now.
Sir, I've forgotten the name you call it. I see slang or sang.
Sang, you are correct. You are correct. That's the name we call it. So let's go to case 2 now.
Yes, sir.
In case 2 here, we're having the f of x to be polynomial. And in this case, you see that the polynomial is of order 1. Look at f of x very well. You see that f of x is what? 3x minus 2. And then in that case, the order of the polynomial will determine the nature of the particular solution. Are we all together now? Now, if you look at this case now, you notice that, let me disable my camera so that my network can get me where. Okay, now let's proceed now. Now, look at this very well now. In this case, we're having the differential equation to be 2 d square y dx square minus 11 dy dx plus 12y equals 3x minus 2. So let's first of all consider the complementary part now. If you are to consider the complementary part, we are going to force the f of x to be 0. So in that case, we assume the solution, then we get our particular complementary solution to be a exponential 3 over 2x plus b exponential 4x. Now, let's now proceed to the particular solution now. In this case, we need to assume, what we are to assume is ax plus b. You will notice that the order of f of x will determine the order of the function I must assume. Do you want me to come over again? Now,
yes, the line is broken.
Okay, everybody. Okay, sorry, I think it's raining. Let me ask this question. Imagine that my f of x is quadratic. Everybody, listen to me very well. Assume that the f of x is quadratic. That is something like 3x squared minus 2x plus 1. Who can tell me what will be the assumed particular solution?
A squared
plus bx
plus
then
c
plus c. So in that case, I will need to find my a, my b, my c, isn't it?
Yes, sir.
Thank you very much. Now let's go to the third case now. The third case is when f of x is exponential. Now let's consider equation 1. We are to obtain the solution of the square y dx square minus 2 dy dx plus y is equals to 3 exponential 4x. Looking at this case, we see that the f of x is what? Is 3 exponential 4x. So how do we go about it? Let's start. The first thing we need to do now is that we first of all assume the solution. And what do we assume? We need to assume my y is equals to EMX, as you can see on the screen now. As you can see on the screen. So by the time you assume your y to be EMX, then you need to differentiate twice. I'm differentiating twice because I'm solving second order. Now, by the time I'm through, I need to substitute back to the problem. By the time I solve back to the problem, then I need to factorize exponential mx. Do you notice that exponential mx is the assumed solution? So it can never be 0. But m squared minus 2m plus 1 is equals to what? Is equals to 0. Then the next thing is this. You need to solve this quadratic. And I believe all of you in this class, in this room, you can solve this quadratic. But there is a name we call it. That is what we call auxiliary. We call it auxiliary equation. Okay? You know, in this case, we are having the same root, which is 1 and 1. Isn't it? So
Yes, sir.
let's proceed now. What is now the complementary solution? The complementary solution is now what? Ax plus b in a bracket multiplying by exponential mx. You know, m is 1. Then you have 1x. Now, you notice that here, I've added x to a. X is multiplying a. Why? Because I don't want to obtain a trivial solution. So the next thing now is that we need to proceed now and now focus on the second aspect. Now, in this case, you will notice that our particular solution, we need to assume k exponential 4x. Why am I need to assume? You notice that k is a constant, right?
Yes, sir.
So I need to determine a. Now look at what I assume again. I also assume exponential 4x. Do you know why I pick exponential 4x? Because the non-homogeneous part is 3 multiplying exponential 4x. So the content of the non-homogeneous part, I mean the content of the exponential, the nature of the exponential will determine the particular solution that I must assume. So in this case, I need to assume something like a constant multiplying exponential 4x. Now, let me now present this concept of D operator to you better now. It's still the same thing you know before, but let me explain to you now. If I take my D to be D dx, then I'm going to take my D squared to be second derivative. Are we together now? Now, you notice that if I should return this one back to the problem, you notice that this is the problem we are solving.
Yes, sir.
You see now, that's the problem we are solving. So now, if I should factorize y out of here, you notice that what I will have will now be d squared minus 2d plus 1 in a bracket multiplying by y, which is 3 exponential 4x. The next step I'm going to do now is that I will replace y with the assumed particular solution. Are we all together now? Now, look at this step now. You know, I'm still writing the same thing, but here, instead of writing y, I'm going to write k multiplied by exponential 4x. I'm returning my y to be what I've assumed. So this is the problem we are solving now. So what is the next step now is that I need to find my k. Then how do I go about it? You know that I can expand. Let me show you again. Look at here. You know that I can expand, look at, there's a bracket here. And this same thing as d squared multiplying by k exponential 4x. And what does that mean? It means that I need to differentiate k exponential 4x twice. Now, let me expand the other one again. Minus 2d times k exponential 4x. What does it mean? It means that I need to differentiate k exponential 4x once. Then I will multiply my answer by 2. Then here, I don't need to differentiate anything. I will just multiply. So that is what I mean that we need to expand. That expansion means that each of the components of D will take the assumed particular solution. So let's proceed now. So that is what we can see here now. Can you see what we can have? We have right now. So I've expanded now. This is what I'm having. Now, look at it now. I need to differentiate this one twice. How do I differentiate exponential? If you differentiate the first time, it will give me 4k exponential 4x. If I differentiate the second time again, it will now be 4k times 4, then exponential 4x. Then that will give me 16k exponential 4x. Now, what about this one again? Hey, there's a mistake. There's d here. There's d here. This is minus 2d. I think you all know.
Yes.
Yes, sir.
Minus 2d. So here now, I need to differentiate this one once. So this one will give me minus 2 times 4. So that will give me minus 8. Then k exponential 4x. So this one, I don't need to differentiate, then I will have it the same thing like this. Now look at the 16 minus 8 plus 1. That will give me what? 9. 16 minus 8 is 8. Then plus 1. You know that all of them, they're having k exponential 4x. So that will give me 9k exponential 4x is equal to, so from here, you can see now that we can make k the subject of formula. And k will give us 1/3. So you return it back to the particular solution. So particular solution will give you 1/3 exponential 4k. So what is now the final solution now? You know, the final solution is now the addition of complementary solution and what? And particular solution. So we can now obtain our, so this is the complementary solution, then this is the particular solution. Now, you see that we are through with the solution of this problem. Now, that is not all. Let's go to example number 2 now. In this example, we have to solve this problem, but look at it very well. You notice that the non-homogeneous part is exponential 3/2x. Are we together?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
I will not talk too much on this, but how do we solve the complementary? You know, for you to get the complementary solution, you solve the complementary part. Then I think you know this. But look at this problem. In this problem, you have your M1 to be 3/2. You will have your M2 to be -1. Then what is the complementary solution now? The complementary solution will now give us A exponential 3/2x plus B exponential -x. This is my equation 3. But look at it. Now, you will notice something. In the complementary solution, look at what I'm having. You know, I'm having exponential 3/2x.
Yes, sir.
Now, go and look at the non-homogeneous part again. In the non-homogeneous part, you will see exponential 3/2x again. Can you see there?
Wow.
Yes, sir.
Yes, sir.
This is another case now. So let me share the note with you now. So look at it. I said, note that one of the components of y complementary is exponential 3/2x. And then the non-homogeneous part f of x is equal to 5 exponential 3/2x. Do you notice that?
Yes, sir.
Yes, sir.
So this is a strange case now. So because of that, do you know what we're going to do? We are going to assume we are going to assume a particular solution to be k without multiplying by x. Do you notice that I've added x to this now? The reason why I've added x is because one of the components of the complementary solution is also in the non-homogeneous part. So that is why I said x. So let's proceed now. Using the operator. In the operator, we know that our d is what? D dx. And what about our d squared? Is d squared dx squared. Now, if you return this back to the problem, look at what you get. You now have 2d squared y minus 1dy minus 3y is equal to 5 exponential 3/2x. Now, look at the next thing now. The next thing is that I can factorize y. If I factorize y, then I will change that y to be my particular solution. So what is the next thing now is that I will return my y of p. You know that my y of p is what? Is kx. Ks exponential 3/2x. So it's equal to this. Now, look at the next thing now. You know, the next thing now is to expand this. And if I'm to expand this, what I will have will now be 2d squared multiplied by what? Ks. So what does it mean? That I will need to differentiate this one twice. Then I will multiply 2 by it. Then for this one, I will need to differentiate it once. Then I will multiply it by -1. And for this one, I will only leave it as it were. So I will have this. Now, let's now start the real problem now. The next thing is that how do we, you know, we have to differentiate this one using product rule. Do you notice?
Yes, sir.
Yes.
So, looking at this one now, you know that this one is the same thing as you keep x, you differentiate exponential 3/2x, isn't it?
Yes,
sir.
sir.
Then you keep exponential 3/2x, then you differentiate x. That is
Yes, sir.
for the first differentiation. You know, you have to differentiate twice. But let me show you a secret. Let's start from here. Let's start from the first derivative. For the first differentiation, here you have to differentiate it. So let's do this together now. If I should keep my x, then if I should differentiate exponential 3/2x, you know, I will have k multiplying by x, then you know 3/2 will come down as numerator. If you have to differentiate exponential, If I differentiate exponential,
Yes, sir.
okay, then it will now be plus. I will keep exponential 3 over 2x, then I will differentiate x, then I will have 1. We'll have this. Now, if you look at this one very, you know that we can factorize. We can factorize k and exponential 3 over 2x. If we factorize this one out, you know what we have? We now have k exponential 3 over 2x, then into brackets 3 over 2 multiplying by x, then plus 1. Are we together now? So this is the first derivative. Now let's go back to second derivative now. Now let's look at it now. To differentiate the second, to differentiate twice, let's break it down. 2d, then multiplied by the first, you know, this is the first derivative.
Yes.
You see that this is the first derivative now. So you now have 2d, then into bracket the first derivative. Now, this one again, you know, for us to differentiate this one, we need to first of all expand. Then after expansion, we will now need to differentiate using product rule. Are we all together? Are we all together?
Yes, sir.
Yes, sir.
Okay, so I don't think I need to explain this again. So after that, you substitute back to the problem, then you factorize. Now, let me now show you the whole screen now. Look at the whole thing now. If you see my screen now, you now notice that by the time you do this first side, the third, second component, then the third, this is what you obtain on the screen. So now we are going to compare the coefficients now. If you look at it, you see that the first one is 9 over 2k multiplied by x. We cannot take that one because x is already there. Look at the second one, 6k, then exponential 3 over 2x. We are going to use that one because we are having 6k, x is not there. Look at the third one, minus 3 over 2x, k exponential 3 over 2x. We are not going to pick that because x is there. Look at the fourth one, minus k, then exponential 3 over 2x. We are going to pick it. Now look at the next one again. The next one is kx. So what I'm trying to do now is that I'm trying to equate the coefficients. So this k minus k will give me 5k, isn't it? Then is equals to 5. You know what I'm trying to do here is I'm trying to compare the coefficients. So this one will now give me 5k exponential 3 over 2x, then it's equals to 5 exponential 3 over 2x. So for me, I can see that my k is what? My k is 1. So I will return it back to the assumed solution. That will give me ks exponential 3 over 2x, then it's equal to x exponential 3 over 2x. So what is the final solution now is that we now have y complementary solution plus y particular solution. So now let me now show you this problem now. Everybody look at this classwork, please write it down. Look for Biro and write this problem down. Everybody, write this problem down. Write it down.
Okay.
So the classwork is that we have to obtain the solution y of x of this problem. And if you look at this problem, you see that without wasting our time, we can actually see that the non-homogeneous part f of x is exponential 3x. So which means that we can solve it. We can solve it. I believe we can solve it. Hello, class?
Yes, sir.
I said I believe we can solve this.
Yes, sir.
Because you are all through with your TMAs. Now, but before we go, let me give you the step to follow. Look at the first step. The first step is that you are going to assume the solution y equals to exponential mx, isn't it? Then you differentiate twice, isn't it? Then you go and look for the complementary solution. Are we all together?
Yes, sir.
Now, when you look for the complementary solution, you will now see that you keep your answer. Now, you need to assume a particular solution. In this case, look at it now. You can assume your particular solution will be what? A exponential 3x, isn't it? Then you need to find a. So you follow the same procedure. Then you find your a.
What are you doing outside?
Now, this is what you are going to get as a solution. You are going to have something like C1 cos 2x plus B sin 2x. Now, in this case, who can tell me the solution of the, someone should tell me the solution of the complementary part.
C1 cos 2x plus B sin 2x.
No, that is the complementary solution. I mean, we are going to have one particular auxiliary equation.
Okay.
So what would be the solution of that auxiliary solution?
2i.
It's about 2i.
2i.
Okay. What would be, in that case, the solution will be in terms of complex number. Complex number. Then what would be the real part? Real part is what?
Real part is 1. No, it's 0.
Who says 0? Real 1, Tayo, and another lady says 0.
0.
You are correct. I didn't get that person.
Yes, sir.
A lady said 0. A lady discovered that as
Deborah,
well.
sir.
Deborah.
Deborah.
I got it. That's a voice. I get it. So in that case, you notice that by the time you solve the auxiliary solution, you are going to have is 0. Then the imaginary will now be too high. So you do that, then you get the solution. So what will happen is that I will give you guys from now till tomorrow morning to send me the full solution. But that is the solution. That's classwork 1. You are through with your TME. That is assignment number 1. So let's proceed now. Can you all see my screen very well?
Yes,
Can you all see my screen? Okay. Now look at it now. You can see the problem. Now we are going to proceed now to the case of trigonometry. What if our f of x is trigonometry? Now, everybody, look at this problem. I think you can all solve it. Look at this way. Can you all solve it?
Yes, sir.
It's very simple. What we are going to assume, what the particular solution we are going to assume will be what? A exponential x. Because you can see now that here, we can see the complementary solution that there is no exponential s here. Can you see there?
Yes, sir.
Yes.
You can see that we are having a exponential 3x plus b exponential minus 2x. So there is nothing like that. So in that case, we are good to go. Now let's take a look at solution number 2. Bam! Look at number 2 now. In this case, you can see now that here we are going to have the non-homogeneous part in the complementary solution. Can you see there?
Yes, sir.
Yeah.
Because by the time you solve for the complementary solution, you are going to have a exponential 4x plus b exponential minus x. And by the time you have exponential minus x, and in the non-homogeneous part, you notice that. So in this case now, the assumed particular solution will now be what? Will be kx. Will be what? Kx exponential minus
x.
So that is okay. Now look at this one now. You see that this one looks like your classwork. Look at this. Hello, everyone. Look at number 3. You see that number 3 is more or less like your classwork.
Yes, sir.
Yes, sir.
In this case now, we are going to have the solution of the auxiliary equation to what? To be 0. Then that will be 3i. So let's jump. Now, everybody, look at number 4. Look at number 4. Number 4, you see that in this case, we are going to have equal root. Do you notice?
Yes, sir.
Who can tell me what will be the root? The root of the auxiliary equation?
1/3.
1/3. Thank you very much. That will be 1/3. So then, by the time you, I think this is even good for classwork. Everyone, look at it very well. Number 4 is good for classwork again. Look at it. Do you notice? Not only that you have equal roots. Look at the solution. Look at the particular solution there. Can you see 2/3 t squared? Who can tell me in this class why do we have t squared there? From here we can see that. Look at this one very well. Everybody, are you all with me?
Yes, sir.
Yes.
You see that in this case, if you are to expand the complementary solution, you have it what? At exponential 1/3t plus b exponential 1/3t. Now you see that we are having the non-homogeneous part is in the 2 of them.
Yes, sir.
Hello, class, are you with me? Please.
I can hear you, sir.
Yes, sir.
You know that in this case, if you are to expand, you have the complementary solution to be at exponential 1/3t. You see that we're having exponential 1/3t in the first solution, in the first component. Hello,
Yes,
class.
sir.
We're having
Yes, sir.
exponential 1/3t in the first component. In the second
Yes.
component again, you are also having exponential 1 over 3t. So if you are to assume a particular
Wow.
to be t multiplied by, you see that if you are to assume t multiplied by exponential over 3t, you see that you are still having that one in the solution again.
Yes.
So in this case, you cannot assume k exponential 1 over 3t. So the next thing is that you consider adding t to it, right? Even if you add t to it, you see that it's still in the solution again. Are we together?
Yes,
Yes,
sir.
sir.
You need to go for t squared.
Wow.
Are we all together now? Are we all together?
Yes, sir.
So you need to go for t squared, because if you add t to it, you will have it to be at exponential 1 over 3t. So you need to go for the squared. So that is on that. So I think we are good to go. Now look at number 5. You know, number 5, in this number 5 now, we are giving the condition. Look at number 5. Is number 5 initial value problem or boundary value problem?
Initial.
Initial value.
Initial value, because we are to find the two constants a and b, and the two conditions are given at s equals to what? S equals to 0. Idris, please, you are making noise. Now let's look at this one again. Look at this one again. If you look at this one, is this one, this is also initial value problem, right? Because the two conditions are given at t equals to 0.
Yes, sir.
Okay, so now let's go to the next aspect now. So the next one now is that when our f of x is sine or cosine. Do you know what it means? It means that if my f of x is trigonometric, but tan is not there, it must not be tan. It does not work if it is tan. Do you know the reason? You notice that in the when you solve the, if you solve, by the time you solve the complementary solution, you know, we have 3 cases, right? And in the case of complex, we are going to have sine and cos. Do you notice?
Yes, sir.
Let me show you again. In the case of complementary, in the case of where is it? Look at it. Can you see my screen now?
Yes, sir.
In this case, look at the case now. You know, in this case, we are having it to be cos and sine.
Yes, sir.
That is why we cannot use that method for if it is tan, if f of s is tan. We can only use this method if we have it to be what, sine or cos. Are we together now? So let's look at number 1. Let's solve number 7 now. Number 7, we have to solve this problem. I believe all of us can solve the complementary part, but let's look at it. Now, let's proceed to the d operator now. In the case of d operator, you know that d is dy dx, y d square is d square, y dx squared. Now, look at it. If that is the case, now you see that in this case, this one will now give me 2d squared plus 3d, then minus 5, then multiply by y. Are we together? Then
Yes, sir.
that will give me 6 sine 2x, which is the non-homogeneous part. Now, what is next thing now is that I need to replace my y. But before I proceed, let's take a look at the complementary solution now. In the case of supplementary solution, everybody look at this. You know, by the time you substitute, you assume your y equals what? EMX. Then you substitute, then you have it like this. You have 2m squared plus 3m minus 5 is equals to what? Is equals to 0. So by the time you solve the 2, you see that your m is 1 and your m is minus 5 over 2, which I think I don't need to explain this. But let's focus on the real issue at hand now. Now, in this case now, this is the case of 2 roots that are different. So we have this to be our solution. Now, how do we solve? What we need to assume a particular solution now for this case of sine and cos. Look at what we assume. We are going to assume y of p to be equal to a sine 2x plus b cos 2x. Now, look at the assumed solution. Why do you think I assume sine 2x and cos 2x? Someone should speak. Why do we need to assume 2x and cos 2x?
Because the other part of the equation is in form of sine 2x, sir.
Thank you very much. Because we are having the non-homogeneous part to be sine of 2x. Are we together now?
Yes, sir.
So because we have it to be 2x, so we are going to assume a particular solution that is A cos 2x plus B sine 2x. That is the reason why I picked 2x, because the nature of the, don't forget I've said it earlier, that the nature of the assumed particular solution is dependent on the non-homogeneous part. We're going to use non-homogeneous part to know what we are going to assume. You can't just assume anything. You need to assume something that is within the range of the non-homogeneous part. So let's proceed now. So if that is the case now, you know that this is the operator. Look at it now. We're having it to be 2d squared plus 3d minus 5, then into bracket my v. So I will now change my v to the assumed solution. Look at it now. Can you see it here?
Yes, sir.
Yes, sir.
So multiplying by this. Do you know the next thing is that I will expand. If I should expand, 2d squared, we take this. 3d, we take this one. Then minus 5, we take this one. Are we together now? So
Yes, sir.
if we proceed now, you know, here now, the first thing is that I will have d multiplying by the assumed particular solution. Now look at this. You know, this one means that I will need to differentiate sine 2x. Do you notice?
Yes, sir.
I will need to differentiate cos 2x.
Yes.
Then I will get this expression. Now look at it again. If I'm to do the second differentiation, that will give me d squared of my assumed particular solution. Do you know the next thing is that this is still the same thing as d multiplying by the first derivative. You know that what I like
Yes,
is this, because you've differentiated it once already. So you just need to differentiate what you've differentiated. So that will now give me, by the time you differentiate cos 2x, you know, it gives you something like minus sine 2x, but 2 will come outside, 2 will multiply 2a, then will give me 4a. Now, if I have to differentiate sine 2x, I will get cos. Then 2 will come outside to multiply this one. So the next thing now is that I will come back to my d operator. Then I will now return everything back. By the time I return it back, then I will equate to what? 6 sine 2x. Then I will now compare the coefficients. How do I compare the coefficients here now? In this case, you will see that everything that has to do with sine, that will give me what? Minus 8a sine 2x, isn't it? You know, I will not take this one because this one is b and it's also cos. Are we together now? Then I will come back again. Then I will pick 6a. No, I can't pick 6a. Then I will pick minus 6. I can't pick this one. Then I'll come and pick minus 5a. Are we together now? So look at it. Minus 8a. Then
minus 5a.
Let me highlight this.
That will be minus 13a sine.
That will be minus 13a. Then let me go to the family of b. So the family of b again, I will pick what? Don't forget that I'm picking b and sine. Don't forget, you know, I'm picking the coefficient of sine 2x. Please notice. Hello, class. I'm picking the coefficient of 2x. For this one now, I will pick this term.
That's 2b sine 2x.
Then I will pick what again? Is there any b and sine? No, there's no. So this is how we obtain equation 1. So I'll go back again. I'll go and pick the coefficient of 2x.
Okay.
So let's pick the coefficient of 2x now. I will start from minus 8b cos 2x. No, I'm wrong. I'm looking for a and cos. So this is the first one now. That will give me 6a cos 2x. Is there any a again and cos?
No.
So I will have 6a here. Let's go back again and pick b and cos 2x. Look at this one again. I'll pick this is a b 8 minus 8b cos 2x. Then is then and look at another one again. Minus 5b cos 2x. So what is minus 8b minus 5b? That will give me minus 13b. So that's how we obtain this. Then you notice that the non-homogeneous part is 6 sine 2x, right?
Yes, sir.
So 6 sine 2x will be for this one. So for this one, sine 2x will go. Then for this one will give me 0. Do you know how we come up with 0 here?
Yes, sir.
So because the non-homogeneous part is not dependent on cos, it's only dependent on sine. So I will have my, so looking at equation 1 and equation 2, I think we can solve this one simultaneously.
Yes, sir.
We can solve, yes, we can, I will say no.
Yes.
Question 1 and 2, we can solve it simultaneously. Then by the time we solve it, we find our A and B, return it back. So this is our particular solution now. So by the time we have our particular solution, then we have the final solution. So let's go and solve another problem again. In this case now, we are going to solve the one that has to do with cos. Now, let's look at what we're having on the screen now. On the screen, we are to solve this problem. Look at it. It seems this problem is very beautiful. Look at the problem. We have to solve the square y dx squared plus 16y is equals to 10 cos 4x. And this is an initial value problem. Do you notice that? You notice that this is an initial value problem.
Yes, sir.
Okay, because we are given the two conditions at x equals to what? 0. Now let's start the solution now. The first thing now is that we first of all solve the homogeneous parts, which will give us the complementary solution. Now let's take a look at this now. We have the square y dx squared plus 16y is equals to 10 cos 4x. Now, do you know what we're going to do here is that we use the operator. Do I need to explain this? Hey, but look at this. I think we can also solve this up to this place. Now, but now look at this now. By the time we forcefully, by the time we are looking for the homogeneous part, then we now have this square plus 16b is equals to what? 0. So when we solve that one, this one will give me this is my auxiliary equation now. Can you see my auxiliary equation? This is the auxiliary equation. So in this case now, you see now that our m is what? Is 0 plus or minus I4. So what is the solution now? The solution will now give me exponential 0. You know, 0 is the real part. Then a cos 4x plus c sine b sine 4x. So this is the complementary solution. Are we together now? So let's proceed.
Yes,
Let's proceed and solve for particular solution. Now, in this case of particular solution, what do I need to assume? You know, I'm to assume what? I'm to assume, what am I supposed to assume? Hello, class, please, can you please help me? What do you think I'm to assume as a particular solution here?
A sine 2x plus b cos 2x.
Do you notice that what you're telling me to assume is already the solution? Hello, class. Hello, class. Hello, class. Are we together? What you are telling me to assume is already the solution, is the complementary solution. Do you look at that? Hello, class.
Yes, sir. Yes, sir.
Let's look at the first problem now. Let's look at, you know, in the first problem, we have it what? 6 sine 2x, right?
Yes, sir.
And look at the if you look at the complementary solution now. If you see the complementary solution, you see that in the complementary solution, we have it what? A exponential x plus b exponential minus 5x. You notice that in that case, we can assume a sine 2x plus b cos 2x. Do you notice that?
Yes, sir.
Yes, sir.
In this case, it is correct for us to assume a sine 2x plus b cos 2x because none of them is in the complementary solution. So let's look at the second solution now. Let's look at the problem. But look at this one we are solving now. In this problem now, you will see that when we solve this case, what we obtain as our complementary solution is what we are supposed to assume. Look at it now. Can you see this? This is exactly what we are supposed to assume. So we are not going to assume it again. We are going to assume x multiply. Are we together now? Are we together? Now you now see that x is multiplying what I'm supposed to assume. But here, I cannot use A and B again because I'm having A and B in the complementary solution. I also need another constant multiplying what I'm supposed to assume as my particular solution. So that is why here you now see that we are to assume x multiplied by c sine 4x plus d cos 4x.
Yes, sir.
So that is what we are to assume in this case now. So let's now proceed. So by the time you assume this now, let's go back to the method we know before. Then we have this, then we change our v to the particular solution that we are supposed to assume, isn't it? Then you expand. This square will multiply everything like this. Then 16 will also multiply everything like this. Then you notice that you need to differentiate using what rule?
Product rule, sir. Or function of function.
Good one, thank you. So we are to use product rule because we are having two functions multiplying themselves. So let's proceed. In that case, we now have what is going on. So I think all of you can do it. Can you guys do it?
Can do it, sir.
Okay, let's take a look at the solution. Let's look at it together. Now let's look at the first one. D is multiplying their zone particular solution. So X will multiply. Then you have to differentiate using product rule, right?
Yes, sir.
Then you differentiate the second time again. Are you getting now? Then you return it back to the problem. Then it's equals to what? Cos 2x. Then you now compare the coefficients. Then when you compare the coefficient, then you find your solution. Now, let's now take a look at it now. Before we proceed, let's look at question number 3. Let's look at question number 3. Everybody, let's look at this question number 3 very well. Let's look at it. Can we solve question number 3? If you have to solve question number 3, look at it very well. Can you solve this question?
Yes, sir.
Okay, look at it very well. Look at it very well. Look at it very well. Can you see the particular solution? Hello, everyone.
It will be complex, sir.
It will be complex. And you will now see that.
Yeah.
So now, everybody, please copy this question number 3 down. Copy it down. Copy it down. That will be your second classwork. Please copy it down. Copy it. Second classwork. I've given you the first class.
Number 3?
Yes, number 3. Number 3, oh, you are solving it. Oh, you are through with your TME. Oh, yeah. Number 3. You are through with your TME. Oh, yeah, number 3.
So how to solve it now?
Just write the question down first. This is as I classwork 1.
Okay.
This is classwork 1. I think you've all copied this one down.
Yeah, we have it. Yes, sir.
And I even explained to you that this is what we have as a solution. Please write the solution.
Yes, sir.
Very sure. Okay.
Yes,
Then classwork number 2. You have to solve this problem. This is what you are going to get as a solution. Please write it down.
Okay.
Okay. Question number 3 is very simple. I've seen the solution. You cannot solve number 3, please. Don't solve number 3.
Excuse me, sir. Please, let's do it like that. So
We've copied it, sir.
we've copied it.
It's very simple. Question number 4 is what we are going to solve. Because question number 4 is an initial value problem. Question number 3 is very simple. Look at you. And I know that you can finish a big bowl of semo. You cannot solve big problems. I know the kind of food you normally eat. So look at question number 4. Can you see there? The square y dx square minus 3 dy dx y is equal to 3 sine x. Then here we are given that when x is 0, y is 0. That's condition number 1. When x is 0, the y dx is also 0. So we have to solve it. So you have this as a solution. So now let's go to another case now. The next case now is the case of sum and product. Hey, ah la la. Now look at this case now. Ah la la. This is the case of ah la la.
Not satisfying the example.
I'm not the one that will set your example. Seriously, I'm not.
He's not the one that will send you.
I'm not the one with
what
not set
it. But it's wrong.
It's very wrong. Seriously.
It's very wrong.
It's very wrong. It's just like in my university, I'm teaching a course, and then they now ask another person to come and say the question I'm teaching. It's very wrong.
So wait, actually, at the end of the day, it's not a facilitator that takes.
Now let's go to problem number 9. Don't let us talk about what is very wrong. We are living in a society whereby we don't like to talk about what is wrong. So, and that is what is affecting all of us. All of us. And that is actually, if you go to mortuary, you will see many people there. It's also because of all this thing. They know what is right, but they want to do it the way they like. So let's proceed. Problem number 9. Let's solve this. We have to solve this problem. Looking at this one now, you see that this is the combination of polynomial and trigonometric. Look at f of x very well. Look at f of x. F of x is the combination of 12x You know, the polynomial here is the polynomial of order 1. Do you agree?
Yes, sir.
And
Yes.
if you have the non-homogeneous part to be polynomial of order 1, what are we supposed to assume for the particular solution? We have to assume what? AX plus B.
AX plus B.
Thank you. Now, what if it is trigonometry like sine? We have to assume A cos X plus B
plus sine
sine X.
B sine X.
Thank you very much. Now, let's take a look at how to solve this problem now. Now, looking at this now, let's use any method, just like I've explained to you. Please follow the method I've explained to you. Then if you do that one, you solve, you look for the, homogeneous, we look for this complementary solution. And everybody looking at this, do you see that this auxiliary equation is correct? That is m squared plus n minus 6. We all know that it is correct, isn't it? Look at it very well. So we don't need to talk about it. And if you are to solve this quadratic equation, you have to have your m equals to 2 and m is equals to what? Minus 3. So in that case, what will be the solution? The solution will give me, what will be the complementary solution? The complementary solution will give me ax 2x plus bx minus 3x. Are we all together? Are we all together with it? There's no problem. Yes, sir. Everybody's yes. I know there's no problem with the complementary solution. Everybody's yes, sir. So now let's focus on the real problem. You know, people always say that in mathematics, you will teach what is simple in the class, then you now set the techniques I'll be using. Now, let me tell you the contrary to it. In my lectures in footer, I will teach them what is simple and what is hard. Are we together? And I teach them everything. So they are already familiar with what is hard. So when we now see the exam, they know, they know. So let's proceed now. Now, let's look at it. You know, I've said something. Please, let's go back again. In this case, our f of x is what? 12x minus 50 sine x. So what should be the assumed particular solution? That will give me what? For the polynomial part of order 1, we have ax plus b. Then for the trigonometric, we have, so now let's take a look at the solution. Let's proceed. I think we are good to go now. Let's look at it now. Since the right-hand side of the given differential equation is the sum of a polynomial and a sine function, let us assume, look at it now, ax plus b, because we have polynomial for that one. Then we have c sine x plus d cos x, because we have trigonometry, which is sine. So we combine the two. So let's proceed now. This is the major problem now. Yeah, let's look at it one after the other. So you go back to the operator, isn't it? Then you factorize. When you factorize, this is my y. Then when you factorize, then you now have your yp. So when you have your yp now, then this is it now. So what is my yp? My yp is the assumed particular solution. So my yp is now ax plus b plus c sine x plus d cos x. Oh yeah, let's do it now. We expand, right? We expand, right? So which means that we need to differentiate the assumed particular solution twice.
Yes, sir.
We need to differentiate it once. Then we have minus 6 multiplying it, isn't it? Now let's take a look at the first one now. This is the first one now. The first one is this. You have d multiplying this. If you differentiate ax, you have a. If you differentiate b, you know b is a constant, it will disappear. Because if you differentiate constant, it's 0. Now, if you differentiate c sine x, you have this. Then if you differentiate d cos x, then you have minus d sine x. Are we together now?
Yes, sir.
Now let's go to the second derivative now. Second derivative, we have this square multiplied by the assumed particular solution. If you differentiate, you know that we are differentiating what we have here. We are differentiating what we have differentiated. Do you remember?
Yes, sir.
So if you differentiate a, which is a constant, you have 0. If you differentiate c cos x, are we together now? Then you have minus c sine x. Then if you differentiate d sine x, then you have this. Then let's substitute everything back to the problem. By the time you substitute everything back, then do you know the next thing? You expand, then you now equate the coefficients. You know, before we've been equating the coefficient of sine and cos, but in this case now, we need to pick the coefficient that has to do with x and sine x. So when you do that, then you compare, then you find your A, B. You know, in this case now, we are looking for A, B, C, and what? And D. Do you agree with it? You know, we are looking for A, B, C, and D.
And D.
So by the time you compare the coefficients, you will notice that A minus 6B is 0. You keep that one. You compare the coefficient of x. You know, excuse me, please. Question 1 here is the coefficient of constants. You know, we have constant here. You know, we have constant A. A is a constant, right?
Yes, sir.
So for constant A, we have this one. Then for x, we have minus is A is equal to 12 for x. Even from here, you know, you can easily find our A from here because A is the same thing as minus 2 here. If you put this A back to equals to 1, you know, we can find B.
B.
Yes.
So we find Aderisola, say it again. Let me hear you. Aderisola, say it again. Let me hear you. Aderisola, speak.
Sorry, sir. No, sorry, sir. The light was sparking here, so I wanted to drop some.
You are welcome back. You are welcome back. So let's proceed again. Now, the next thing is this. We need to look for the coefficient of cos x. Are we together? So you pick the coefficient of cos x again. Then you have C minus 7D is equal to 0. You keep this one. You look for the coefficient of sine x. Then you have this. Then you know that equation 2 and 3. We can solve it simultaneously to give us C and D.
Yes, sir.
So you solve it, then you find this to be your particular solution. Then you now add it. You know, we have to add the particular and the complementary solution together. So we have this one as our final solution. Now let's stop here so that there won't be headache. There won't be headache. But you know that I gave you 2 classwork already now.
Yeah.
This is classwork 1.
Sir.
This is classwork 1, and you've copied it down.
Yes, sir.
Let me show you tax.
Question 2.
This is question 2. Please, I believe you've copied that, isn't it?
Wait,
No, sir.
sir,
Wait.
please just hold on like this. Just hold on like this.
I will hold on, Baje. Don't worry, I will hold on. Okay? I will hold on. Tell me to hold. I will hold on for you because I don't want to. Okay. Please copy it down. You are asked to find the particular solution, but this one is initial value problem. So by the time you find the final solution, which is after you've added the complementary solution to particular solution, you cannot stop. You know, you need to go and find A and B. So, so the one you do for particular solution, that one is already embedded in the final solution. So you need to go again to find the coefficient of the complementary solution. You know, in the complementary solution, you are going to have a coefficient, A and B. So you use this one to find it. So, I think, I guess you are true with the solution, right?
Yes, sir.
So now, what will not be classwork number 3? Classwork number 3 has to do with the mixture. There's God, though.
How is that number 3 for class?
There's God.
Number 3.
Look at this one now. Classwork
Which
number
one?
3. I will body. Don't worry, you will see clearly. Look at this now. Can you see it very well now? It's very beautiful. Beautiful question for intelligent students. Oh yeah. Now we have to find 8 d square y dx square minus 6 dy dx plus y is equal to 2x plus 40 sine x. Whoa. Now look at it. We have to solve this one. But don't forget the method we are using. The method is called what? Undetermined coefficients. Please don't forget. Are we all together?
Yes, sir.
This method here is called undetermined coefficients. So next class, I will call your attention to another method called variation parameter. So next class, we'll talk about variation parameter. So have you all copied the question down now? Okay, now you will now solve question 1, question 2, a classwork, and then the 3 classwork. I want to do something with our WhatsApp group. You know, in our WhatsApp group, we have so many people there, and many of them, they are not responding, and it's really hurting me. It's paining me. You know why I'm here now? I'm here because they said many of you guys, you are ready to learn. That's why I'm here. That's why I'm using my data. I'm using my money to buy data. So, and I would not like it. Some people should stay in that WhatsApp group and they are not ready to do anything. So I want to remove them. I must remove them. I must remove. I've been giving you signal for the past 3 weeks.
You've been saying it since.
I've been saying it, but I don't know how to do it. And I want to do it. I must do it. I must do it.
Don't beg on their behalf.
Now look at it this way. Do you know that many of them, they are looking at it as a difficult problem. They don't even know how to start. But what will not be my gain if I'm wasting my resources? See, I'm doing everything. No, I must do something. No, I must do something. So what will happen is this. So please, by the time you post your solution to me on WhatsApp, please keep it. I will still need to create another platform so that you can upload it. So that at the end of the day, I will present all this video to National Open. I think you know that. Hello, students.
Yes,
Hello.
sir.
Wow.
So all this video, I'm to present it. That is why we are using e-learning platform so that they can see everything. Are we together now? Even our WhatsApp group,
Yes, sir.
I know that many members,
Yes, sir.
the staff, some staff may be inside the WhatsApp group just to see what we are doing. Are we together? So
Yes,
being an external person, they must see everything we are doing. So by the time you send the solution to me, please keep it. The same solution, I will now design a platform on e-learn so that you can upload it directly for National Open to see. But the one you are sending to me via WhatsApp, I want to use it to remove some people in that WhatsApp group. So when I remove it, then they will beg me before they say I should add them back again. And if they didn't beg me, then if they beg, I will not ask them to go and solve it and bring it. So by the time they solve it, you know, one thing is that I will remove everybody. Then I will delete the WhatsApp group. Then I will create another one. Then as you are coming in, I'll be using that one to enter you guys, to add you. So I'll be the one to add because the link of that one is already out. So that's what I would do. So please, by the time you solve it, please keep the solution. Are we together? We shall call it a day at this point. Thank you very much for coming. I really appreciate you guys. Thank you very much.
Thank you very much.
Hello,
Quick
sir.
question.
Hello,
Sir.
Hello, sir. The assignment.
Yes. What is the assignment?
Yeah, please, can you give us like 2 or 3 days to solve it?
Yes.
Okay, don't worry.
Sir.
2 to 3 days.
Yes, sir.
Yes.
Okay.
Okay.
Wednesday as deadline,
Yeah,
sir.
wait. If you want me to give you 3 days, I will add one question to it, making 4. But if you want me to give you between now and tomorrow morning 3 questions, but if you want me to make it on Wednesday, should I add one question to it?
It's better.
Should I add a question to it?
It's better, sir. It's better.
Let me tell you a story in my university.
We have other assignments, sir.
You are a university student too. In my university, do you know what am I? Let me share with you my university. By the time wait, let me tell you what I've been doing for my students in my university. By the time they write my first test, all of them will fumble, and I will now give. I say, should I use the test or I should do another test? Then I say, we should do another test. Then we do another test again. They will still fumble again. I'll ask them, do you want me to use this one? I should do another one. They say I should do another one. We do another test again. So before you know it, before we get to the exam, want to settle like 5 tests. You understand? So it's the last one that will now mark. But by the time you are marking the last one, you will see beauty. You will see the beauty of math. At times my student will be teaching me. You will see the way they solve problems, and they have to solve line by line. They know you can't jump for me. Like it's only in exam that I can give students the opportunity to jump, but in test or classwork, that shall not jump. That's my stand. That shall not jump. Don't jump any step. So by the time they are writing the 5th test, what is smart already? They are already wanting look and crazy. So in the exam, they will just be flying. So that's what I've been doing. So the question is this: 3 questions you submit tomorrow, or 4 questions on Wednesday.
That will be 4 questions.
Sir,
Oh yeah,
before on Wednesday, better.
That one will be thick also.
4 questions. 4 questions on Wednesday. 4 questions on Wednesday. Oh yeah, look at question number 2. But let's look at question number 2. In question number 2, we're having two combinations. We're having our non-homogeneous part here is 2 sine 2 theta minus 4 cos 2 theta. Look at that very well. I know you cannot solve it, but you need to go and check my lecture. Go back. In this, all of you have this material. Go and look at how they've solved this one. Let me show it to you now. Okay, everybody, please copy it first. Copy it. Copy the 4th question.
Hold on, sir. Hold on, sir.
I'll hold on, don't worry. I'll hold on for you. I'll hold on for you. Eh? When I want you to solve 5 questions.
No.
Oh yeah, it's 4. It's 4. Yeah, copy it. Copy it. Oh yeah, it's 4. Oh yeah, copy it. It's 4. I will not make it 5. I should make it 5. Eh? You want me to make it 5? I will not make it 5. Oh yeah, are you true now? Have you all copied the question down? No,
not yet.
Okay, please copy it down. You know, in this case now, our dependent variable is what is y. Our independent variable is what is theta. And this is second order linear homogeneous and non-homogeneous. Second order linear non-homogeneous. So, and we are to using the method of undetermined coefficients. And in this case, f of x is a combination of sine. It has sine, it has cos. So we are to solve it. Okay, now why you are through with that now? You will go back to this material. There is a place where you can see hints on how to handle a problem like this. Let me show you. Okay, we look at 51.6. 51.6 is not a good example. Let me show you another. But looking at it, look at problem 10. Problem 10 is the combination of exponential and cos, isn't it? Yes. So it seems problem 10 is not a good example for that, for question number 4, for the classwork 4. It's not a good example for question number 4. But look at this one. Look at this again. Let's look at this again. You know, here we have polynomial and trigonometry, right?
Yes.
And
Yes,
we assume one for this. We assume another one for this, isn't it? Isn't it?
Sir.
We are going
Yes,
to think. Go and use this one to think on how to solve classwork number 4. Go and use the concept to think. Go and use the think. Then I think if you think about it very well, you will see how to go about it. In that case, the particular solution will not be something like what? Look at the problem now. Look at the problem. It will be like something like what? Who can try? Look at it now. Even looking at the solution, you should be able to look at it. Look at the solution. What would be the particular solution? The particular solution should be something like what?
Oh.
Complex.
What would be the assumed particular solution? Hello, class. Look at it very well. What do you think should be the assumed particular solution? You know, we're having f of x to be 2 sine 2 theta minus 4 cos 2 theta. So what do you think should be the assumed particular solution?
Sir, can we say, can you hear me, sir?
I'm hearing you, Bajabaje. Oh yeah, speak.
Sir, can we say it will be a sine 2x?
No, we can't use A again. We can't use A. We can't use
Okay,
A. We can't use A and B.
Okay, sir, I understand, sir.
C
sine 2 theta plus d cos 2 theta all squared, sir.
You are very correct, but I will not say you are perfectly correct. But when you write it down, you know, I know the rule for.
I thought that was, sir.
You know, you can use mouth to cook, but by the time you get to
sir.
the kitchen, you see that is another ball game. Because I know that we have many female students in the class, and they will soon start making justice of it. So you know, you can use mouth to cook, but by the time you get to the kitchen, and you know that it's not as simple as that. But based on what you said now, I think you can try it. Assume C sine 2 theta plus D cos 2 theta. Then at the end of the day, you now see that your C and D will be 1/2. Your C and D will be 1/2. C is 1/2, D is 1/2. So go and do it. So thank you very much for coming.
Thank you very much.
Yeah. Is there anybody that would like to say anything?
Hello, sir.
Hello, I can hear you clearly.
Sir, the last class, part of the class, and I tested the upload of the.
Oh yeah, send it to me on WhatsApp. I will send the link to you. Send it to me on WhatsApp. I will send the video. Even this one too. I will put this one on YouTube very soon now. Today's class.
Thank you very much, sir.
Hello, sir. I have a question, sir.
Oh yeah, speak.
Hello, sir.
Hello.
Sir, can you hear me, sir?
I can hear you. Read one, Tayo.
Sir, when we started this homogeneous linear, we talked about superposition, sir. So this undetermined coefficient that we are adding complementary solution and particular solution, is this also application of superposition, or because
No.
Oh.
The only application of superposition is this. Look at it. Look at this. Can you see my screen?
Yes, sir.
Yes, sir.
The solution we have here, we've used the concept of superposition because we are having. Do you know that in this case, exponential x cos x is a solution? Do you know?
Yes, sir. Yes, sir.
If you look at exponential s cos x, it will satisfy the problem. Even if you look at exponential s sin x, is also a solution. So what we are trying to do now is that we now add a and b to each solution, then we add the two together. That is what method of supposition.
Okay, sir.
But the method we are using to solve this case of non-homogeneous parts now is what we call undetermined coefficients. Do you know why we call it undetermined?
Yes,
Because by the time we assume a particular solution, we put some constant there that we don't know. That's why I call it undetermined. We don't know what the constant C and D may be. So we will not be the one to not determine it by ourselves. And how do we determine it? We use the operator, because you notice that we need to differentiate what we assumed. So by the time we are doing that, then we use the method of comparing the coefficients. Then we now determine the coefficient. That's why we call it method of undetermined coefficient. Okay, thank you everyone for coming.
Thank you,
I
sir.
really appreciate
Thank you very much, sir.
So yes, I can speak.
I'll be very glad if the video can be uploaded.
Hey, do you know one thing is that immediately I stop now, my sister, I will need to download it. Are you getting me now? I will, we are using Zoom. So I will download it, then I will now send it to I will now upload it. But don't worry, I will be very fast about it, okay?
Thank you, sir.
I will need to on the generator now. Okay. Thank you very much. Thank you for coming. Okay.
Thank you, sir.
We appreciate it, sir. Thank
You're
you, sir.
welcome. Yeah, wait, let me see your face. Wait, don't go. Let me see your face. Who and who in the class? Let me, so that if I should see you on the street, I should be able to identify you guys. Okay. So thank you very much. I think you can see my face. I know many of you very well. So Riwa, I know you can go. Bye bye. Riwa, go. Riwa, I can see Quadri, Akim. What's the center? Okay. Kano. Okay, Mekati. Okay. Thank you. Adekunle, you are new. Adekunle, yeah. I can see your
I've always been your class, sir.
No, I'm still. Aderisola Yatoye. Aderisola, please let me see your face. Aderisola, I need to see your face, please. Let me see your face. So.
Okay. I don't know.
Which partner big
Okay,
names?
Priscilla, call up Priscilla. How are
Yes,
you?
sir. Good evening.
Good evening. Aderisola,
Yes,
I can
sir.
see you now. So if I see you, I think I should be able to identify you. Don Oko. Okay,
Sir, I'll send you a message on WhatsApp, please.
Come again.
I said I'll send you a message on WhatsApp.
Okay, thank you very much. I'm expecting it.
Yes, sir. Thank you.
Yes.
Nothing Oladebo, sir.
Oh, yeah, speak. Hey, Oladebora, where are you? Oladebora, I think she has gone. She has gone. Okay.
Yeah.
She was around, I saw. Maybe. Yeah, speak.
This topic we are taking, I'm making reference to a particular book. Which page of the book? The one you sent to
Are you in a WhatsApp group?
Yes, sir.
Okay, don't worry. I will send the book again for those I've just joined. Not some people have just joined the WhatsApp group. So I will send the book again. I will upload it again. Don't worry. Okay. And maybe you joined very late. I will send the book again.
Yes,
I'll do that. Ayenadeto.
Yes, sir. Well done, sir.
Always present.
Well done. Greetings to you. What's the
Yeah, thank you, sir.
Hey, is this your baby?
Yes, sir.
So two of you. Hey, baby, how are you? What's the matric number, baby?
00000.
Is that okay? Thank you very much.
Thank you very much, sir.
Thank you very much.
Thank you, sir.
Musa,
Yes, sir.
how are you?
Yes, sir. I'm
Sorry, sir,
fine,
please
sir.
quick one. The solutions for the assignment should be dropped on the WhatsApp, or you give us a link to
No,
where to
you
drop
send it to
it.
me. Send it to me privately.
Okay, sir. Okay, sir.
You send it to me privately now. So immediately you send it to me privately, I will save your number.
All right, sir. Thank you very
I'll
much.
use that one to add you back. So please, you send it to me privately.
All right, sir.
Oh, one copy. Doesn't mean that they will copy everything. Don't send it to WhatsApp group, or they will copy everything.
All right, sir.
Oh, yeah, Adekule, please let me see your face. Adekule. Oh, yeah. Okay. Sorry. I've seen your face. Abdulkarim Uma. John Oko. Please show your face. Abdulkarim Uma, you're in the office. You're in the office.
Abdulkarim Uma, yes.
Let me see your face. It's your face I want, not your office. It's your face. So that if I
You're not going still no lights.
Okay. Sorry about that. Maybe some other time, okay? I think we still need to meet like 2 or 3 times again before we end the lecture, okay? Now, thank you very much. Thank you very much. Thanks for coming.
Thank you, sir, for your time.
That's your family, sir.
You're welcome. Thank you. Bye-bye.
Bye.
Yeah.
Bye.